In this video, we're looking at geometric growth and decay. So geometric sequences and series can be used to describe what we call as growth and decay in real-world applications. So for this, I'm going to actually just jump into some questions, examples, and we're going to work our way through it to help show you how we solve these. So the first problem we have is that the price of shares in a particular company is falling by an average of 2% each day. The first question asks us, what percentage of their initial value do they have after 2 days? So essentially what we're trying to do is if I have Tn here, ARN, where Tn is going to be the percentage after so many days, and then A is going to be our starting value. In this case, we don't have a starting value, so we will just assume it's 1. R is going to be how much it's increasing or decreasing each time. All right, or what's the value change? N is obviously the period of time. So in our case, N is going to represent days. So if we're after T2, A we said is 1, so we don't need to put it in there. Now, it's going down by 2% each day. So what that means is every time we go down 2%, we actually have 0.98 or 98%. All right, so each time we're going down our 2%, our value left over at the end is 98% or 0.98. All right. So each time we have 0.898 because we're not trying to find how much it's going down by. We're trying to find out what the new value is. So instead of dealing with the 2%, we're going to be dealing with the 0.98 or the 98%. So for 2 days, we're saying 0.98. And our N we said was 2. Now, you can just put that straight into a calculator and you get 0.9604. Now, if I want that as a percentage, we're going to times it by 100 and we get 96.04% after 2 days. So the next one, approximately how many days will it take for the shares to halve? So this time we're actually given a value or a goal and we need to find the days, so the N value. So if we still write this up here, our Tn equals ARN, our Tn this time will be our goal, and our goal was half, 50% or 0.5. All right, R is still going to remain the same as our 0.98. We always said that our starting value is 1, so we don't need to worry about it. And this time we're trying to find N. So if I substitute these into our formula, 0.5 equals 0.98 to the power of N. Now, I want that N, so the opposite of our index or our power is our natural log. So what I'm going to do is we get natural log of 0.5 equals the natural log of our 0.98 N. Now what this allows me to do, if you remember your logarithmic rules, is this N can be brought down the front. So what I end up with is ln 0.5 equals N ln 0.98. And at this point, it's just basic algebra, so I'm going to divide by my natural log here. And it also goes over here. So what I'm left with is 0.5 over, let's put these in brackets just to make everything kind of neat, equals N. So at this point you can put this in the calculator. So N ends up being 34.3, or if we just round it to 34 days. It'll take 34 days for the share price to halve. Alright, so we're looking at our number C now. After how many days will the shares be worth 10% of their initial value? So this is very similar to what we just did then. So Tn equals ARN. And in our example, Tn is going to be 0.1, which is 10%. R is still our 0.98. A is still 1, and we're trying to find N. So 0.1 equals our 0.98 to the power of N. use our natural logs again. Our n comes out the front because of our logarithmic rules. We're going to divide by this over here as well. So they cancel out, and we're left with n equals 0.1 over 0.98. Alright, and you put that in the calculator and you get 114 days. Alright, so now we're going to look at another question. This time we have a tree. Alright, so we have the 8 centimeter seedling, grows by 4.8 centimeters in the first week, and then keeps growing by 0.6 of its previous week's growth. How tall will it grow? So what we're looking for here is our limiting sum. Alright, so our limiting sum. Now there is a formula for this. Oh, not an 8, an S. Our limiting sum, which is just represented by S to infinity, is A over 1 minus R, where A is your starting value and R is our change. So in our case, A is our starting value, which is 8 centimeters, and my R is the 0.6 or 60% that it's growing every week. So 8 over 1 minus 0.6. We use a calculator and we get 20 centimeters. So our limiting sum is 20 centimeters. So what that means is that the seedling will only grow to 20 centimeters, and at that point it stops growing. All right? While it will grow little tiny bits, they're so insignificant that we don't count them. To recap the video, we covered a range of things. On your screen, you'll see a bunch of formula that may be used when you're coming across these type of growth and decay problems. So you've got your limiting sum at the top, which we used. We have our term value, which we used a variant of, where we didn't have the -1. And we also didn't see, but is commonly used, is our sum value, which will find the sum of our sequence. All right. So as you can see, A is always representing the first value. R represents the change. N represents the time period.